In the digital age, data traffic is growing at an exponential rate. The demands on computing power for applications in artificial intelligence such as pattern and speech recognition in particular, or for self-driving vehicles, often exceeds the capacities of conventional computer processors. Working together with an international team, researchers at the University of Münster are developing new approaches and process architectures which can cope with these tasks extremely efficient. They have now shown that so-called photonic processors, with which data is processed by means of light, can process information much more rapidly and in parallel. Background and methodology. Light-based processors for speeding up tasks in the field of machine learning enable complex mathematical tasks to be processed at enormously fast speeds, 10 to the power of 12-10 to the power of 15 operations per second. Conventional chips such as graphic cards or specialized hardware like Google's TPU Tensor Processing Unit are based on electronic data transfer and are much slower. The team of researchers led by Professor Wolfram Pernice from the Institute of Physics and the Center for Soft Nanoscience at the University of Münster implemented a hardware accelerator for so-called matrix multiplications, which represent the neural networks are a series of algorithms which simulate the human brain. This is helpful, for example, for classifying objects in images and for speech recognition. The researchers combined the photonic structures with phase-change materials (PCMs) as energy-efficient storage elements. PCMs are usually used with DVDs or Blu-ray discs in optical data storage. In the new processor, this makes it possible to store and preserve the matrix elements without the need for an energy supply. To carry out matrix multiplications on multiple data sets in parallel, the Münster physicists used a chip-based frequency comb as a light source. As a result, this enables highly parallel data processing by calculating on all wavelengths simultaneously, also known as wavelength multiplexing. Our study is the first one to apply frequency combs in the field of artificially neural networks, says Wolfram Pernice. In the experiment, the physicists used a so-called convolutional neural network for the recognition of handwritten numbers. These networks are a concept in the field of machine learning inspired by biological processes. They are used primarily in the processing of image or audio data, as they currently achieve the highest in contrast to traditional electronics, which usually work in the low GHz range. Optical modulation speeds can be achieved with speeds up to the 50 to 100 GHz range. This means that the process permits data rates and computing densities, i.e. operations per area of processor, never previously attained. The results have a wide range of applications. In the field of artificial intelligence, the use of larger neural networks allows more accurate, and hitherto unattainable, forecasts and more precise data analysis. For example, photonic processors support the evaluation of large quantities of data in medical diagnoses. Further applications are in the fields of self-driving vehicles, which depend on fast, rapid evaluation of sensor data, and of IT infrastructures such as cloud computing, which provide storage space, computing power or applications software. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.